Our lesson today is graphing proportional relationships, and our goal is that we can represent proportional relationships on graphs. So our first thing here is we have a graph of proportional relationships. Two lines are shown on the graph below. The red line shows a proportional relationship. The blue line does not. What are the differences between the two lines? So if we look here, the red line is straight or linear, and the blue line is curved. Or it has a kink in it, really, kind of. And another thing is the red line goes through origin. The blue line starts up here, which is a difference also. So when graphed, proportional relationships are straight lines that must go through the point 0, 0, also known as origin. Okay? All right. So here's our first example. The black mamba is the fastest snake in the world. The table shows the distance the snake travels for several different times. Is the distance the snake travels proportional to the time? So here's what I want you to do. I want you to pause as you need to. You can graph this with me. I might graph a little faster than you do, so if you need to, pause it as needed. You can rewind if you need to also. So we start with, this is our x-axis, this is our y-axis, and we graph, this is our x, this is our y. So we look, we've got 0, 0, so this is our point here, so there's one of our requirements. We have 1, 5, so we go to 1, we go to 5, that's this point right here, and 2, 10, so I go to 2, I go to 10, 3, 15, right here, and 4, 20. And I believe that is 15, 16, 17, 18, 19, 20. All right. Always want to make sure that you make the, that you mark at the cross there, like that, and here like that, okay? Not in between the lines. Notice how we've done that there. So if you look there, you can see that I do, in fact, make a straight line. Now, you got to bear with me here. I should have a straight line there. Did I graph that correctly? Yes. I think I might be off. All right. I should be a straight line. Got to bear with my drawing a little bit, but my line is straight. So the answer there is yes. And does it go through the origin or 0, 0? The answer is yes. So in answer to the question, is it proportional? Yes, it is. All right, on to our next one. A candle is 20 centimeters tall. It burns at a rate of 2 centimeters per hour. Is the height of the candle proportional to the number of hours it burns? This time, create the table to find the height of the candle after 0, 1, 2, 3, 4 hours. So if it starts 20, it is 20 centimeters tall, right? Okay, and then it burns 2 centimeters per hour. So after 1 hour, it's going to be 2 centimeters shorter, or 18, and then it's going to go down 2 centimeters each hour after that. So hopefully you guys would not have problems filling that in. So to graph this then, we'll stick with the same color. So we start here. All right. Sorry, I had to actually mark my marks. So 20 at 0 hours, so it would be here. And then at 1 hour, it's going to be 18. At 2 hours, it's going to be 16. At 3 hours, it will be 14. And at it 12, 4 hours, it should be 12. So, we connect those. Okay. So my questions are, is the line straight? The answer to that is yes. And then, does the line go through origin? The answer is no. Therefore, it is not proportional. On to our next one. The length of the stretch in millimeters of a spring is proportional to the weight in grams attached to the end of the spring as shown in the graph. What is the constant of proportionality, or the unit rate? To find the constant of proportionality, we find the value of x when y is 1. So, to do this, if you look here, says find the value of x when y is 1. So we look here, if we've got when x is 1, y is 5, right? So now we got to figure out when y is 1, what is x? So how are we going to do that? I knew something about that sounded fishy. I was thinking that through. And this should be the value of y when x equals 1. Okay, that makes more sense. So when I look at this, x, what is y when x is 1? So if we look right here, when x is 1, y equals 5. So our constant of proportionality, so we're looking right here. I kind of want to point right here where we've made that mark. Constant of proportionality is 5 in this case. Okay? All right, now moving on. Okay, on our own. Scroll this down a little bit. We don't need to see the on our own. Graph the following relationships to determine if they are proportional or not. If the relationship is proportional, determine the constant of proportionality. So, we're going to graph. I need you guys to pause them and come back and graph them and come back on your own and check with me, okay? I'm going to pause it, graph them, you come back and check. Okay, so I just finished graphing these, and you can see by the first one that you should always extend your line, even though your points don't necessarily go there, but you should always extend it through through wherever it's going to go, all the way through the axes. So in this case, when I extend my line, it hits the x-axis, not the y-axis, and on the red line. Sorry, you can't see where I'm pointing. So when I extend here, sorry, that didn't quite go through the way I wanted, but you can see where it goes, that it's going to cross at 2. So it's going to cross the y-axis somewhere over here in the negative range, right? So it is not going to go through origin. So it is linear, yes, but it is not going through 0, 0, or origin. No origin. So no constant of proportionality, right? Okay. Number 2, when we look at it, it is linear, and it goes through origin. Check. So then our next question is, what is our constant of proportionality? So when I look, when x is 1, what is y? And I don't know if you guys are seeing this real clearly right here. I'm making the note. X is 1, y is 4. So our constant of proportionality is 4. All right. Hopefully you enjoyed this lesson, and I will see you next class.